Good afternoon, everyone. I am Hamada-NLP-based from Politecnico di Milano. During the handover phase, a large amount of information is transferred from design and construction phase. So some of this information is unstructured information, while some others are structured information like BIM. But when we want to export this information, some of data can be lost. So manual efforts are required to extract information from these unstructured documents or to recover the lost data, to provide complete COBie file to be used during the operation of the facility, because COBie file is more accessible format, can be used during the operation and management of the facility. However, this process is time consuming, so expensive. So NLP as a subfield of artificial intelligence, computer science, and linguistics can perform this task more effectively. So now I will present how NLP can be used to support building management. The proposed methodology consists of three steps. The first step is data preparation, information extraction, and information integration into COBie. From the first step, we developed the labeled data to use it to extract information, to train the model to extract information, and to evaluate its performance. So if the performance is not okay, we can try another model or to increase the labeled data. If it's okay, we can start the third step, and finally to get the enriched COBie. To develop the labeled data, we need to define information schema to know how to structure the information. At the heart of this schema, we have the object. Object has a unique ID, existed in a specific section, has a description, has a reference, require a specific action to be realized. Action has a description, has a constraint to be executed, has a reference. Also, object has attribute with a value. This value has a constraint, has a reference, and measured in a specific unit. To use this schema, we need to remove untextual parts from our collected documents, and to upload these documents with the schema to Label Studio platform as a software to manually label our data, and finally to export the labeled data, the annotated entities with their relation, as we see here. For information extraction, the information extraction pipeline is: we have a text, apply named entity recognition, extract entities, apply relation extraction model, define the relation between each two entities, repeat the process, and finally to get the structured information. To apply this pipeline, transformer-based model is used as model architecture. As we see here, the text is tokenized, embedded inside the model, and finally the classification for each token is obtained. Then highlight the position of these entities and submit it for relation extraction model, repeat the process again, and define the relation. To train the model and evaluate its performance, to do this task, the labeled data is divided into three data sets. The first one to update the model weights or model parameters. The second data set to set up model hyperparameters. The third one to test the base model and to evaluate its performance. So now we have the structured information, we have COBie format, and we need to integrate the structured information inside COBie format. So a classification model will be used to identify each object sheet, and then a rule-based model will be used to insert the information related to each object inside this sheet or inside other sheet related to this object. For example, we have a specification of wall specification. We apply the information extraction pipeline. So entities with the relation are extracted and defined, then insert this information inside COBie format. As we see here, internal wall is a system. We insert information about the ID, the description of the wall, and then we have coated plaster board as a component, and then attributes related to these objects are inserted inside attribute sheet. For experiments, wall specification documents in Italian language were used as a case study, Bert and Roberta as a language model, and executed by PyTorch and on Google Colab. For the training, data set was split into this percentage, and these are the final parameters used for all the model. And precision recall F1 score were used as evaluation metrics. For the results, as we see here, for named entity recognition and relation extraction task, Roberta model has achieved the best performance. Of course, maybe it's logical because Roberta model has 24 layers and 550 million parameters. So the model was able to recognize the difference between these entity categories and the relation types. For named entity recognition, some categories have a good performance, and while some others achieved low performance. For relation extraction, most of relation types have high performance or at least moderate performance. To summarize, we propose the methodology to provide an enriched COBie to support design building management, but also the pipeline, information extraction pipeline, has achieved a good performance, but manual efforts is still required to develop labeled data to train, validate, and test the model. In future, we will implement step 3, increasing the labeled data to improve the performance of the model, and also using large language models to perform the task and to compare the results. Thank you for your attention.